Using prime factorizations to find the HCF. Now, prime factorization as a topic and then highest common factor or greatest common factor or HCF have already been explained in the previous videos. I would put the link below so that you would be able to watch it if you haven't. It is important to understand those two because it will help you to understand this topic as well. Sometimes finding the factors of a number and then pointing out its common factors and eventually finding the highest common factor can be time consuming, especially if the number is large enough. If the number is large, you are going to have a hard time writing all the common factors and then finding the highest common factor. And this is where prime factorization shines one of the most. Take the example finding the highest common factor of 84 and 30, for instance. The prime factors of 30 will be this, and that of 84 will be this. Like I already explained, to know how to come by this, you have to watch the video for how to find the prime factors of a number. Now, one would likely miss some of these if care is not taken. Then if you miss them, you would also likely miss the highest common factor, which is 6. Then to make it easier for us, we use the prime factorization. How does that work? Let's see. Take 30. We write its prime factors like this. We know 2, 15 gives us 30. We reduce 15 to 3 and then 5. And that is the prime factorization for 30. 84 can be reduced to its prime numbers in this way. Okay, and then we get this as its prime factors. If you want to write it side by side, this is the index form. Then we get this for that and this for that. Great. So we are interested in this. How do we use this prime factorization to find the HCF for 30 and then 84? Well, we are interested in the numbers that are available in both. So we want to look at the numbers that exist here and then here as well. If the number doesn't exist in both, then it will not help us in finding the highest common factor. So we see 5 is present here but not here. 7 is present here but not here. So we are going to ignore these two. We are going to focus on 3 and then 2 because 2 and 3 exist here and then 2 and 3 exist here. However, you will see we have 2 to the power 2 here, but just 2 to the power 1 here. How do we decide how to use this to find the highest common factor? We take the one with the lowest index, which is 2 to the power 1 or 2, because this one has more 2's than this. And if we are to use this one, it means it will have numbers that are present here but not here. So we are interested in numbers that are available in both of them. And in this case, 2 to the power 1 or 2 is present both here and there. If you use 2 to the power 2, then we will not be able to find the highest common factor. We will only keep the one which has the lowest index. So as this has 2 to the power 2 and then this one has 2 to the power 1, then we are keeping this one. Then for 3, we see that 3 is just 1, or 3 to the power 1 here and then 3 to the power 1 here. So we represent it using any of it at all, which means that to find the prime, to find the highest common factor using the prime factorization, we just use 2 times 3, which is 6. And this is the same as writing the common factors and then finding the highest common factor. And that is more error prone than this. For this, the moment you write your prime factors, you just look at the numbers that are available in both of them. Then you use the one with the lowest index, and in this case it is 2. If the numbers are not present in both, you have to ignore it. If they are present in both and they have different powers, we use the one with the lowest power. and in this case it is 2 to the power 1 or just 2, and then 3 is to the power 1 in both cases. So we just take any of it, then we multiply the two numbers. So 2 times 3, 6 is the highest common factor of 30 and then 84 using the prime factorization. Again, we can use another example. Prime factorization of 51 is this 3 and then 17, and those two are prime numbers, so we've ended. Then 75 is 3 and then 5 and 15, and we can reduce 15 to 3 and then 5, and we have this prime factorization for 75. Now, like we said, we are interested in numbers that are available in both. We can see 3 is here, 3 is present, but 5 isn't present here. 17 too isn't present. 5 is present here but not here. 17 is present here but not there. So what do? We focus on numbers that are present in both, and in this case it is 3, which tells us the highest common factor of 51 and 71 is 3. Okay, if we add 45 to the mix, let's see, 45 is 5 times 9. Now we reduce 9 to 3 times 3, and then we get this. Alright, now if we are to find the highest common factor of these three numbers using prime factorization, then we look at all three factorizations. What number is available in all of it? 3, 3, 3. 5 is here, 5 is here. Unfortunately, 5 is not here, so we would ignore it. 17 too is present here but not there, so we would ignore it. 3 has a power 2 here, it has a power 1 here, and then a power 1 here. By our rule, we are keeping an eye on the lowest power, the number which is available in all of it and in the lowest power, and it is 3 to the power 1. So the highest common factor of the three numbers is 3, taking into consideration that it is the only number that exists in all of the numbers and has the lowest power. So HCF, or greatest common factor, for 51, 75 and 45 is 3.